Malaysia, the sewage is discharged via a modern sewage system, and on a daily basis, the sewage treatment company Indah Water Consortium manage 5 million litres. A wastewater treatment system contains a number of procedures. First is the preliminary treatment, where screening happens to remove any trash or debris from entering the plant. Then it is passed through a settling tank for the primary treatment. Here, small pieces of plastic and other floatable substances such as grease will be skimmed off the surface. Other heavier organic waste such as food and organic waste will sink to the bottom and be collected as primary sludge. After that, a secondary treatment process will undergo the influent. Air is pumped to the aeration tank to make heavier particles simpler to be removed, and heavier sediments will sink to the bottom. Most of the secondary sludge is combined with the primary sludge for further thickening and digestion, and some of it is transferred back to the aeration tank to help maintain the mix of helpful microorganisms to process the incoming wastewater. It is then disinfected to remove any harmful bacteria to release the water into local waterways. All the sludge will be gathered and is thickened to separate the water from the solid material. It is then placed into tanks called digesters, and most of the material is converted to methane gas, which is a biogas. Furthermore, there will be remaining solid materials called biosolids left after dewatering, which can be composted and used for agricultural uses or further processed for other beneficial uses. The biogas released during the sludge digestion can be used to produce heat and electricity for the wastewater resource recovery facilities. Once purified, it can be distributed as renewable natural gas for the community. Recovering and reusing biogas enhances clean air operations and significantly reduces the greenhouse gas emissions.
The problem statement of our open-ended project is as follows. Wastewater is produced in large quantities daily, which leads to several problems like water crisis and environmental damage. Hence, solutions that provide us with the opportunity to create zero waste is crucial. However, there are several limitations of the current control system process used in wastewater treatment plants. Therefore, the utilization of a more intelligent algorithm compared to the classic PID algorithm is paramount to solve issues of the PID parameters that are difficult to alter. Next, I will be talking about the objectives. Firstly, it is to study the reverse osmosis process as a waste management technique for wastewater treatment plants. Next, it is to examine the application of a modern predictive control, MPC, compared to a classic proportional integral derivative PID control system in the reverse osmosis process. And lastly, it is to determine the challenges and limitations of current control system application in wastewater treatment industry.
The wastewater treatment process begins with collected sewage removed from residential and industrial areas. The sewage water undergoes screening process in which solid and wastewater are separated. Then it undergoes sedimentation process followed by coagulation and flocculation process. This process takes place to separate the sludge particles. Then biological treatment takes place where trickling filter and anaerobic sludge process are implemented to attain 99% of pure water. Then solar evaporation process happens where the water is heated to get pure water followed by ozonization process. Finally, reverse osmosis technique is used to get consumable water outlet product. Now the sludge and solid waste is taken for the conditioning process followed by dewatering and thickening processes. Then stabilization process takes place to reduce the acid and alkali contents, continued by sludge digestion process where microorganisms decompose the organic matter present in the sludge and converts it into more stable substances and release the methane, biogas, which can be used to power plants, and biomanure, which is fertilizer. Remaining waste products are taken for incineration. Thermal energy and pressured carbon dioxide from incineration process are used to generate electrical energy. After this process, carbon dioxide from turbine is taken to CO2 extraction process to form pure oxygen to use as an aeration product, and remaining ashes formed is taken as fly ash. The ash products which settle down in the chamber is given as composite material for construction industries. Hence, the final products of our zero waste initiative is reusable water, biogas, biomanure, electricity, fly ash, and clean oxygen.
The operating company can specify the design of the plant's control concept according to its hierarchy, from highest priority to the least priority as shown in the pyramid. To prevent fouling and to restore the output of permeate to a specified level, plant operators are required to manually increase the high pressure set point multiple times each day. The change in set point may lead to a high gradient in permeate flow, permeate salinity, and pump speed. Shown here is the schematic diagram of a wastewater treatment plant. An MPC controller based on a benchmark simulation model number 1, BSM1, is used in the process. MPC controller provides better nitrate concentration over a classic PID controller as the result is more stable and has less variations. In terms of DO concentration, MPC control is less efficient than PID. However, it can be concluded that MPC control strategy performs better overall for disturbance rejection. This is because of the relatively minor offset caused by the MPC control of DO concentration as compared to the significantly reduced offset caused by the MPC control of nitrate concentration. A benchmarking simulation was conducted to compare between PID and MPC in a 40-hour time span. The 4x2x0 MPC control was created with 4 control variables and 2 manipulated variables as listed. The results of the benchmark simulation are shown here in this slide and this slide. To ensure the output is close to the set point, the plant operator is required to manually change the feed pressure set point. Hence, a sawtooth-like graph can be observed when using PID controllers. When the set point is made, the controller's actions will cause a disruption to the plant operation. Next, a comparison of key performance indicators by PID and MPC controllers can be summarized here. Smaller variations are observed in MPC. The usage of MPC over PID provides several advantages to the plant's operation, such as reducing water salinity range and higher automation level in production process. It also reduces pump speed gradient, which prevents wear out. MPC provides results with higher stability and smaller variations in all the key performance indicators, as well as it reduces the energy consumption.
Moving on to the recommendations on current process control. Firstly, cascade control should be implemented. It allows early identification of permeate flow rate disturbance, enhancing the effectiveness of primary variable control. Next, feed flow rate offset could be eliminated, which is advantageous for RO process. This is because the time to reach the set point value is decreased. Next step that could be taken is using ultra low energy or ULERO system. This system uses less electricity since less pressure is required, lowering the cost. The process set point is also decreased, so when disturbance occurs in the process, it does not need as much energy to return it. We also use membranes with smaller diameter but can produce better recovery rates. Lastly, box plant model is not to be utilized. A black box model is used to predict the occurrence of reverse osmosis issues in full-scale plants and enable timely control measures. Artificial neural networks or ANN are another AI technique that use input and output methodology. Another model used is multivariate statistical methods or MVS that monitors wastewater systems and time series modeling for forecast. PCA can also be used in which it helps in prompting appropriate control steps when a plant's performance is declining. Moving on to the recommendations on current process control. Firstly, cascade control should be implemented. It allows early identification of permeate flow rate disturbance, enhancing the effectiveness of primary variable control. Next, feed flow rate offset could be eliminated, which is advantageous for RO process. This is because the time to reach the set point value is decreased. Next step that could be taken is using ultra low energy or ULERO system. This system uses less electricity since less pressure is required, lowering the cost. The process set point is also decreased, so when disturbance occurs in the process, it does not need as much energy to return it. We also use membranes with smaller diameter but can produce better recovery rates. Lastly, box plant model is not to be utilized. A black box model is used to predict the occurrence of reverse osmosis issues in full-scale plants and enable timely control measures. Artificial neural networks or ANN are another AI technique that use input and output methodology. Another model used is multivariate statistical methods or MVS that monitors wastewater systems and time series modeling for forecast. PCA can also be used in which it helps in prompting appropriate control steps when a plant's performance is declining.
To conclude, all of our objectives for this project have been achieved. We have successfully studied about the reverse osmosis process as a waste management technique during wastewater treatment. RO process is widely used in wastewater treatment plant due to its low cost and high energy efficiency during treatment process. We also have successfully analyzed and made a comparison between NPC controller and PID controller, and it was proven that NPC is better suited for RO process compared to PID controller, in which NPC provides better nitrate concentration, produce a much more stable results, and perform better overall for disturbance rejection compared to PID controllers. Lastly, we have successfully determined the challenge faced by RO process, which are fluctuation in feed pressure, disposal of wastewater sludge, and energy consumption. In order to overcome this challenge, we have provided a few recommendations, which are implementation of cascade control, ultra low energy ULERO system, and box plant model.